Hi everyone. Today we will review two contests that's connected today. First one is topcoder single round match number 788, and then Codeforces Round that just finished. We're still awaiting system test results for that one. So let's start with the SRM. I guess it is possible that I will use double speed in some parts of the videos to speed things up a little bit. So today's SRM has rather easy set of problems. First one was a little twist on the classic problem. We are basically given a graph with some edges. Weighted edges. You can the graph is connected. You can remove up to k edges so that the graph remains connected, and you want to remove edges of the maximal possible total cost. So without limit of k, we would just remove all the edges but the ones that are on the minimal spanning tree, the given graph. So here we do basically the same. We just remove, if there is more than k edges, not on the spanning tree, we will remove k most expensive ones. Oh, why is the title reverted back? Sorry. Here we go. Oh, well, nothing really interesting here. We have custom struct edge, mostly generated by ID. The only thing we need to write is basically operator-less for starting purposes. We use the joint set union to check if it's a very standard algorithm to get the minimal spanning tree. We try add edges from the least expensive one to in ascending order of cost, and if newly added edge actually connects something, it is part of MST. If it's not, then it can be part of the answer. You can see I missed part about no more than k edges, which is why we have this answer, but I will fix it shortly. Yep, that's about all that we accumulate. What's left? And Brex, thanks for the follow. Don't hesitate to ask any questions in the chat. I will gladly answer them. Not necessarily about these two contests or their problems. We can talk about anything competitive programming related you want to know. So not this problem not really easy to stress test, I guess, and like not that hard. So I decided to not do stress testing this time around. That would actually apply to all of the problems. This match. So the second problem is the only one that was kind of non-standard in this match. So you have basically a grid h times w. Some of the borders, like some of the edges between neighboring cells are, how would you say it? Like some of the pairs are separated by some kind of net. You can remove some of those nets, and after you done with removal, all the connected components of in this grid should be rectangles. So this is kind of iterative problem. On each iteration, we will check if all the current components are rectangles, and if a component is not a rectangle, we also calculate for each component like the first and last columns and first and last rows it contains, maximal and minimal. And if like it's not a rectangle, even if it's rectangle, it doesn't matter. All the inside nets should be removed in the bounding rectangle, because basically all these cells should eventually belong to the same component, which should be rectangle, as we can't add new nets. So bounding rectangles of any component should all align the same component eventually. So we can remove any internal nets. You would be able to see that in my solution I actually do not remove nets inside components that are actually rectangles, but it doesn't matter because we wouldn't actually return the resulting grid. We will only return number of components, and doesn't matter if you would remove those nets or not. So yeah, quite standard. We will use BFS on the grid. For that, we as usual need corresponding Boolean array, which we need not to forget clear between iterations. And that's about it. I guess we can put it on the fast forward because there is nothing really interesting here. And it's kind of funny to see me typing that fast. I never actually. I have a confession to make. I type basically with 4 fingers, 2 fingers for actual typing, and then I use my thumbs for white space. Here we have corresponding count as a number of components. If we actually finish on this iteration, then we will return count. Okay, is if this iteration still good. How do we check if the given component is a rectangle? The number of cells should be equal basically to number of cells in the bounding rectangle. That's easy way to check. Here I take some time to understand which actual indices in placement I should query. You can see I use my own two-dimensional and like higher dimensional arrays. And in C++, you actually cannot overload operator square brackets to take more than one argument. So I had to overload round brackets for that. It's actually a nice feature of Kotlin and C Sharp, I guess. There you can overload square brackets for exactly this usage. Here we have the area of the bounding rectangle. Check if it's the same as number of cells we encountered during our breadth first search. And here we will remove all the internal walls. We will also remove internal like classes which are used for spacing, but it doesn't matter anyway. We never query non-vol squares. And that's it. So let's move on to problem. The hard problem, which actually pretty standard, but I don't know. I don't know why it's happened, but it took a lot of time to me to get the solution. So here you have park. Let's say yes, a grid with some cells removed, which corresponds to trees. And you need to divide all the remaining cells into cycles. So what do you need to actually notice? First, need to notice that obviously any two neighboring cells of the say if we will use chess coloring, then any two neighboring cells will be the cycle would be of two different colors. Each cell will have two neighboring cells in the cycle. So what you can do actually do the flow with like or two matchings. It's basically the same edges. Like you have all the cells as vertices, also source and sink. Edges go from like white to black neighboring cells. Then there is edge from the source to each white cell of capacity 2, and edge from each black cell to the sink of capacity 2 as well. And you basically need, well, obviously, number of white cells should be the same as number of black cells, and you also like need for the flow to be equal to the number of the cells. So yes, it's pretty easy, but I think I took about like 10 minutes to actually solve it. I'm not sure. I'm gonna even draw something in this problem. Not sure if it really happened, but after some drawing, I solved the problem, so I guess yes. Guys, you're quite quiet today. What's up? I'm thinking something along the lines like dividing all the cells into dominoes, then doing something like really, I'm not sure. It's like it should be quite straightforward, like quite straightforward flow exercise, but for some reason it took me a lot of time to get it. I'm not sure. Anyway. At least after I've got it, I had coded it quite quickly, but still, even this like really, really bad not bad. Like really unpleasant part about restoring the actual cycles. Yeah, finally, something about chess coloring. And yes, we are watching this on a fast forward, so it actually took me a bit longer than we see here. Yes, finally you can see edges from left to right and right to left. Yes. Here we start the coding. Creating graph is rather straightforward. Target is a number of its target like value of flow. So I'm thinking about how best to do hunter restoration. And yes, we will just restore all the stated edges, put them in kind of table and go from there. Find cycles in the table. I wouldn't mind typing and thinking that fast in reality, but fortunately it's like 2x or even 3x speed here. Standard trick if you need to restore cycle is to have kind of last and last element before current. So you need to take the other element, and the start you can to case one, so you can just assign last to something not possible. JCG, thanks for the follow. Here I had a small bug in my library actually. Reverse edge should be const as well, but I forgot to mark it, so yeah. Here I forgot to fill done. Yes. And thanks to batch test, I can check if solution is actually correct. Yes. And that's it for SRM. After all my problem passed. I was, I think, tense before system testing, before challenge phase, because a lot of people solved last problem much faster and got much more points on it. I actually made 2 unsuccessful challenges on the solutions that will fail system tests. So I was right to challenge it, but for some reason my tests were not enough. But after all, I finished 10th, which is nice because 10th place get 4 points to the stage scoreboard, while 11th place only 3 points. So that was good enough. And after short break, we will move on to Codeforces Round, which was much more interesting in terms of problems. Stay tuned and start to ask some questions, please. And we are back. Let's move on to today's Codeforces round. Yes, I see a question, JCJ. I think problems were quite nice. At least it was interesting to solve them. I had some problems with like easier problems because like I kind of hadn't finished proofs for some of them, and because of that, I got wrong answers on problems A and B. And about problem C, actually, you will see. You will see. I wouldn't spoil anything. But generally, yes, it was nice problems. I guess I was a bit tired by the end of the day. But after all, I've got very nice results. So, yes. So yes, we will go through the solutions, and I guess problems A to D was parts of division 2, and responding a problem C to F. So yes, we will go to all these problems. I solved all the problems but problem F in this round. So sorry. So we will get there. Anyway, we will start with problem A. Here we have two strings. We can select any subset of indices, the strings in the string that have the same character in string A, say X, and replace it with in all these positions with some other character Y. And in this version of the problem, in problem A, we have conditions that Y should be more than X. And if it is possible to convert string A to string B, we basically need to answer what is the minimal number of operations. To do that, otherwise we should print -1. We will print -1 if and only if there is such an index I, so that AI more than BI, because we never can like make value lower. Yes, I will try to up my sound a little bit. And welcome to the stream, Ivan Ilas. Yes, so, and then welcome to the stream as well, Zora. So, what we do next? The correct solution actually that we need to, for each component, like we will have an edge from some character A to some character B if there is a let's say C and D, yes. That if there is position I, such as AI equals to C and BI equals to D. And the actual answer is for each component is number of vertices -1. Or otherwise, number of vertices minus number of components. It's the same thing. So my first solution was wrong. I thought that, well, I'm not really sure why I thought that, but I think that it's a number of, like the same thing, but if all the non-trivial components that contains more than one vertex were in the same component, and it's really incorrect. Like it would be like for the first sample, we can do all in. Oops. No, not for the first sample, but because I just forgot -1 here. For the third sample, we have strings ABC and TSR. And obviously, we need only 3 operations, but this solution, it's like 5, which is obviously wrong. And then I tried to do the same, but like calculate minimal of number of vertices that have outage and maximum of number of vertices that have outage and have image. It's also incorrect, obviously. Yes, but well, it happens sometimes. Like when you're not really in good form and you try to think like, problem A should be easy, so any solution should pass. It's not true. You really need to, like in most cases, you need to have at least some outline of proof. And I have no outline here. So, but unfortunately, this second version passed samples. So I submitted it, got an answer. And then, after some thinking, I finally got the correct solution. So it would be very illustrative stream, I guess, about some errors you can make, some mistakes. Here's some thinking. Finally, correct solution, yes. What tool do I use for submit? I use Codeforces command line tools. I guess if you would Google Codeforces command line tools, you will find it. It's very nice and it helps save a lot of time. So yes, another question was, can you suggest a pathway from specialist to candidate master? Well, I cannot answer from experience because when like I was on the level of specialist or candidate master, there was no Codeforces. When I really started, I like in school, in high school, I participated in math Olympiads, and I started participating in programming competitions when I got to the university in 2002. And the one and only personal competition that was at the time was basically topcoder. Yes, there was like Google Code Jam, but Google Code Jam was staged on topcoder. There was no Codeforces, no like Edcoder, no nothing, no code chief. Like only contests you have is topcoder SRMs. And then sometimes there was some team contest on SGU, Judge or on Timos or on Yuva, stuff like that. And those were quite rare. Like you had contests like this like once every 2 weeks or something like that. So yes. Um, so I can't answer from my personal experience, but like with Codeforces, but what I did at the time is just solved a hell lot of problems in online judges. Like we have we have practice contests with like with not really contests, just like problems bundled together. So we have no one to compare ourselves to, but we have that like 3 times a week, 4 times a week, and that was 5-hour contest. So you just need to practice. That's my answer. And you like now you have a lot of educational materials, say on Codeforces as well. I guess they're good. I hadn't tried, but I would guess they're good. But basically, yes, basically training, training, training. So let's take a quick look at problem B. In problem B, we have an array of integers, and we play a game. Each player alternatively take an integer from array, and after all integers are taken, the one with the biggest exclusive OR of the integers win. So the solution is quite straightforward. First of all, if we will check bits from highest one to lowest one, and then we look at the number of elements of array that have this bit set. If the number is even, then this bit wouldn't how to say it, wouldn't have any influence on the answer, because after all the numbers of array would be distributed, both players would this bit either set or unset because of the way exclusive OR works. So we need to find the first one that is present odd number of times, and whoever had taken that bit odd number of times through the course of the game will win. So basically, it's easy to see, relatively easy to see, that first player will win if either n is even or this bit is present 4k plus 1 times in the array. And if n is odd and the bit is present 4k plus 3 times in the array, second player wins. But I made a small mistake. I for some reason assumed that the limit on A was up to 1 million and not up to 1 billion. Because of this mistake, I've got a wrong answer and spent a lot of time thinking that I made a mistake somewhere. And this really hurt my score in the end, which is unfortunate, but yes. So that's another very very important thing to do, is to check limits, because sometimes they can, for example, sometimes problem is very hard if you have like if you have big if you have big limits on the like values in the array, but very easy if it's really small limits on the numbers of the array. This time I just like have incorrect incorrect limits, which doesn't really matter. Like just need to replace 20 with 30 in the start of the program. But fortunately, I think I will spend the next 5 or 10 minutes just trying to get like counterexample for my for this if, but I kind of proved in my head. So yes, that was unfortunate. We can try to try to fast forward through it because nothing really interesting happens here. Yes, so turning to the questions about how to get better. What you need to practice is basically you need to try to practice problems that you do not solve during the contest. So if you, for example, on some Codeforces round can solve problems, say A, B, and C, and have then problem like cannot solve problem D, then you need to try to solve problems around the difficulty level of that problem D, and like try to solve them for some time, not looking at the editorial right away, not looking at the what it's called tech cloud of the problem, because like it can contain quite um, sometimes hints in the tech cloud can be like the whole idea of the solution. So, or you can just go to some kind of like Timos. Timos is good in that each problem has difficulty that is calculated by a formula, and so you can kind of bin research your current current level. So if you can solve problem quite quickly, you need to look at problems of high difficulty, and if you are stuck for too long, you can lower difficulty a bit and then just solve problems one by one, sorted by difficulty. And it's also very good way to practice. Okay, let's ban this. This person who tried to spam our chat. Bye bye. Anyway, yes, so I'm still kinda just can't understand what happens here. And yes. Try to find some kind of mistake in my reasoning. But there is no mistake in my reasoning. There is mistake in the constants I used. And a good way to avoid that is like do not use any constants like maxn, something like that. One of the reasons is because like you can locally test with vectors so that it will catch like index out of bounds. But if you create vector or array of size maxn, wouldn't be caught on small tests. So another questions from the chat: why had I switched to C++? Well, basically the only reason. Okay, there's two reasons. Last November, I think, or it was like sometimes in the autumn of last year, there was a contest by Yandex where there was no Java allowed. There was only C++ and Python for some reason. I really don't understand that decision, but anyway. And I have to try C++ after like I think I last seriously used C++ in programming contests 12 years ago, in 2008 or something like that. So, and it kind of was good. It wasn't like not really good, but I hadn't like that much more problems that I have in Java. And the other reason is that problem setters really ignored Java for a couple of years now. They wouldn't write a reference solution in Java. They wouldn't really try to get the correct time limit so the intended Java solution will pass. They just don't care anymore. So I kinda got tired by sometimes not being able to get intended solution accepted, and like and with modern tools, C++ is not that bad really. You can check for number overflow. You can check for index out of bounds. You can check for most of the things that make where you can make a mistake and Java will help you. And then after you did all those checks, you can like disable them and solution would be very fast. So that's basically it. You can see that I basically write in the code is very similar to what would be in Java, because like my code style, I got used to that code style, but that's the main reasons, yes. Yes, I'm playing some games on the right. Oh, thank you, Abita. So why do I use Line over Visual Studio? Basically because I used when I use Java, like you don't really have any real like options with Java. ID is just the best. And you may know that I have wrote C-Helper plugin for Java competitions. And then some other guy from Russia wrote like reworked my plugin to work with C++ called ghelper. So yes, and that's the main reason, basically, because I get used to JetBrains IDEs. They are very nice, and I have like bad memories about Visual Studio. like autocomplete wasn't that good at the time, stuff like that. That's the main reasons. And also with line you can use both uh, GNU, C, GCC, and Visual Studio workflows. And most like Codeforces have both Visual Studio and GCC, but most of the judges have only GCC. So to avoid some compatibility, some weird compatibility errors, I prefer to use GCC everywhere. Here I actually use like VSL, which is basically Linux core on Windows to compile my programs. Another questions, what's okay? GCG, I think I already answered this question. It's Codeforces command line tools. You can Google it. I don't really remember where I downloaded it, but there is like a thread on Codeforces. Yes, thank you. A bit of good luck for you as well, and good luck for everyone who will participate in qualification round of Facebook Hacker Cup today. Here we have problem E. Let me slow up speed a bit. So the problem E is about really strange operation. Basically, there is a string of zeros and ones, and you can take two consecutive characters on the string and replace them by the maximum. So if there is two zeros, you can replace it by 1 0. And if there is 0 and 1, or 0 and or 1 and 1, you can replace it by 1. The question is how many different strings you can generate using this operation 0 or more times. So the solution is like this. First of all, we can discard all the leading zeros or the trailing zeros, and then multiply the answer by number of leading zeros plus 1 by number of trailing zeros plus 1. So I did this with right away with leading zeros, but I for some reason decided not to do that with trailing zeros and spent a lot of time that I shouldn't have spent trying to make my solution work. Oh, sorry. Yes, the queue is it is custom tool used by used basically for ICPC Live. It's on GitHub, but it's not really user friendly. Like I just use it for Codeforces because like yes, I written the part that work with Codeforces API, and you can still probably check it out on GitHub. It's, I guess, ICPC Live version 2. It's called something like that, but I do not recommend to try to use it. It's like it's only useful with to use with OBS Studio, which is streaming software I use, and it's quite like it have no documentation. It's really weird, stuff like that. So yes. Anyway, back to the problem. So after we discard trailing leading zeros, the question is we have some kind of string which starts with 1, ends with 1, and then for each one, but the last one, we know how many zeros we want to take. It's some sequence like A0, A1, so on, AK. And we also have a sequence Z, which is like how many zeros are there after the first one, how many zeros after the second one in our string, and so on. How do we check if we can have corresponding sequence A0, A1, so on? We need to we need to find some subset of indices of that, so that say A B0, A B1, A B2. Let's switch to the drawing board. I will show you. Okay. So we have sequence. We have string. Our string is like this. Yes. We want to see if we can convert it to a string like this. We can do it if there is some sequence of indices B0, B1, so BK, such that that B0 is not less than A0, that B1 is not less than A1, and so on. How do we check this? We find the first index in this array that is such that B0 is at least A0, say so somewhere here. And then we see if we can find corresponding find this this subsequence in this part of array Z. How do we actually do it? So if we want to calculate number of strings that are substring of like this part of the strings, starting from here from the tie. So we have some kind of res I. It is equals to, first we can select number of zeros we take right after res I, which is up to zi, so zi plus 1 variance times and whatever string we can create after this one. But suppose we want to take more zeros than zi. Then we find nearest index j such that its minimal j such that j is more than zi. We add answer from j. Yes? And then we subtract part of this that we already included here. So it's zi plus 1 times res j plus 1. And this dynamic is basically what we need to do. And if there is no such j, we also need to, so we wouldn't add this part, but we need to add one, because there is also we can also always can make a single one from our current string. So we need to account for that. But as you can see here, this works only if we have like no zeros after the last one. Otherwise, there is really some real weird problems, like border conditions. And I hadn't did it right away, which was my mistake. Let's switch back to the video. Yes. And let's speed it up a bit, because there is nothing really interesting happens at the current time. I will do some debugging after I finish solution, because I would have like incorrect answers of all on all of the test cases. You can ask why I switched to problem E right after problem B, and that was because problem E was like sure to be solved in the contest. And yes, I came up with some kind of solution right away. And to get like to quickly get the next to quickly calculate index j that we have in our solution, we use standard trick with q. No, with a q, with a stack. Yes, with a stack. And here we have like not a single correct test. And all tests but the last one are not really interesting, because we have always z in the same order. So the only interesting case is the last one. Otherwise, we always will be only in this part of if. Here I'm starting to do something really weird. Adding plus ones, adding minus ones, stuff like that. Don't do that at home. No. That's a bad idea. Oh my. It was very hectic contest for me. But really, you should wait for the last problem, because it would be the weirdest one. problem C, or you can say problem A hard. Apparently there is some complaints about the division 2 round. Sorry, I don't really have any opinion. Uh, I'm a poor judge of problem difficulty myself, so. Here should be pause back plus one. One more stupid mistake. Sorry about that. Give me. I just have my wife and children back. Let's do some more random changes. So, any questions? I'll be glad to answer. Okay, I guess I'm drawing in order. Well, Gennady is not here, I guess. But anyway, congratulations, Gennady. You are now again tourist of Codeforces. Let me write him. Gennady says, yeah. Oh, anyway, finally solved E. And we move on to the D. So problem D. Let's switch back to normal speed. Problem D. You have matrix n times m matrix of integers, and it contains all integers from 1 to n times m exactly once. You have some like set of maximums of rows and set of maximums of columns. You want to create a matrix with the same set of maximums of rows and columns, but with additional properties that each row and each column is bitonic. And bitonic means that it's first, like, it have some index p inside, some index p, and numbers up to p are ascending, and starting from p are descending. So yes, some kind of mountain. And the solution is actually quite easy. So let's switch back to drawing board. Suppose we have we will have max rows, maximum of rows, say, in the array R, and maximum of columns in the array C, and those arrays would be sorted. We will go from n times m down to 1, and we also will have some kind of queue of positions where we can put elements that are not maximum of any row and not maximum of any column. When we also have like some kind of each moment we have some kind of submatrix which contains of some set elements, and also all the other cells in this submatrix are in Q, or yes, as a field or in Q. So we have next element I. If it is in both arrays, then we would put I here. We will add these cells in our queue in this order, and we will add cells in this row in this order to the queue. If it's only in rows, we'll put it here. We will add elements in this row to the queue in this order. The same with the same if it is in only in column maximums. And then if it's neither, we will just get the first elements from Q and put it in corresponding cell. Why the resulting matrix will be bitonic? Basically, if we would like, there would be some kind of path from top left to bottom right cell, which is the elements that were maximum of some row or some column or both. And for each row, first such element would be basically the index that is peak of the mountain. And for each column, the first such element in this column will be the element that is peak of the mountain of this column. And we can see just by the way we build this matrix that these conditions will be satisfied. So I would say this problem is much easier than problem C, which have the same cost. I guess problem C is probably harder than problem E, but I'm not sure, because while I have accepted in problem C, I actually hadn't solved it. That's weird. That's really weird to say, but it's true. I have no idea how to prove my solution, and how I came up with the solution. I actually looked at the the constraints and kind of deconstructed what solution can be expected with such constraints. But we'll see it in a few minutes when we will finish up with problem D. Yes, let's speed up video. Once again, this is sped up video. I don't really type and things as fast. I guess next time I will need to put some kind of context timer somewhere in the overlay. And here I copy pasted correct part. I should have copy pasted column part, but I will fix it quickly. That's not like with problems B and D, where I spent quite a lot of time due to stupid decisions on my part. Fortunately, Codeforces do not have batch testing like topcoder, so here I have to check solutions by hand if it indeed have the same maximums and if it's indeed bitonic. And apparently they are. On to the problem C, I guess. Okay, I actually spent some time on both problem C and F. I hadn't come up with any solution to problem F. Problem F. Problem F statement is you have a graph where you know all the like capacities of all the edges, but a subset of at most 10 edges. And all the capacities are integer up to 25. And you have a lot of requests, up to 100,000 of requests, that say your capacities of that up to 10 edges, and you need to output for each such request flow in the whole graph, where there is up to 10,000 vertices and 1,000 edges. I really hadn't come up with any idea during the contest. I still don't know how to solve it. So yes. And problem C is a harder version of problem A. In problem A, you can only in each operation you can only replace character with bigger character. In problem C, you do not have any such limit. And welcome, of course, Solo stream. So in problem C, you don't have any such limit. And the question is the same. What is the minimal number of operations? Which is a minimum number of operations to convert string A into string B. Question from the chat: which plugins for IDEA? Not really for IDEA. It's not IDEA. It's CLion, which is C++ IDE from the JetBrains. And Chrome do I use? So for CLion, I use a modified version of JHelper. Which is you can find it post on Codeforces. It's really nice plugin, yes. And in Chrome, I use competitive companion, which is also have a post on Codeforces, which helps me getting all the like creating tasks with all the tests in IDE. Yes, Sniper, I guess it's something like that, but like during the course, I hadn't come up with any solution for F. For submitter, it's Codeforces command line tool. Also, as you can guess, you can Google it and find a post on Codeforces. So about problem C, we have what we have there is we know that number of characters is up to 20, which kind of suggests that solution would be some kind of either 2 to the power of n or 2 to the power of n times n or 2 to the power of n times n square. Also, as we have 10 test cases in each test, up to 10 test cases, probably 2 to the power of n times n square wouldn't pass. I'm not sure. Maybe it will, but anyway. So it suggests there is some kind of dynamic solution on bit masks. With that knowledge and not much time left in the contest, I decided just to implement some kind of the first idea that came up. And that is, suppose we have like some submask and some letter, some character. That is of course part of the submask. Now we will build a graph on 20 vertices where have directed edge between them. If you need some index replace like from F to T, if for some index you need to replace, you have F in A and T in B. So suppose you have submask of all characters and some characters in the submask. Now I say that we would have to use two edges. If in the submask we have edges both from F, both from this character like A to some other character in the submask and back from some other or the same character in the submask back to A. Then I say that we can achieve answer 2 plus like result for submask without A. Now suppose there is no such two edges, so there is. Then I say if A lies in the same connected component of graph as some other vertex in the same subgraph in this submask, then we need 1 plus answer for submask without A. And if there is no other vertex from the same submask, then we can just remove it, and the answer is like we can achieve the answer that is equal to the answer for submask without A. And apparently it works for some reason. I still don't know why. This kind of like reverse analytic solutions are very rarely successful. But as I have no time, no idea on problem F, and no other ideas for problem C, I decided to implement it because it's not really like hard to implement, and it worked. And this really worked, yes. Yes, let's try to speed up it a little bit more. Because for a long time it would be just switching between problem C and F mostly, and sometimes looking into the settings. As you can see, by this time all the problems already are solved. But yes, while this time around I couldn't find any proof for my solution, actually using constraints to kind of understand what kind of complexity is really required in the problem is a good idea. But usually you need to come up with a proof of solution before implementing something like that. This is a really exceptional case. So if you have any more questions, don't hesitate. And apparently solving this problem is what got me from what I would be, where I would be without this problem, I wonder. So if you subtract about 1,000 points, oh well, actually it's only 2 spots, but still it's nice. And with this contest, I regain my legendary Grandmaster rank, which is yay. Hello, Drew 414. 414, sorry. Welcome to the stream. Yes, as you can see, I still haven't started coding anything. Oh, finally. Let me see what kind of speed up I have here. I guess the speed is about 2x normal speed. So I do not really type this fast, but Here I decided that there is really no reason to have 2 to the power of n times n square, because we can easily avoid it with bit masks. And yes, I hadn't yet implemented the part about connected components. Yes, thank you. Wonder if your editorial post, I need to see why my solution for problem C is actually correct. Uh-huh. Oh, well, it wasn't intended solution, so I guess it's somehow equivalent to intended solution. That's it. As you can see, there's likely not much pretest in this problem, so I still expected it to fail. But it passed. And I've got 8th place in the competition. Here I try to find if anyone had hacked anyone, but apparently it wasn't really good contest for hacks. And that's it for today. If you have any questions, you can ask them now. Otherwise, I will try to find some other streamer who is doing some kind of competitive programming contest. Let's see if there is anyone. Okay, I hope you know Portuguese. Because I will send you to ALDZ. Give him my regards and thank you for being here. I hope we will have something next week. I haven't yet looked at the have a look at the schedule for next week, but I hope there is some contests as well. Yes, this stream will be available on YouTube. So if you want to review something, you can do it there. Thank you all for being here, and bye-bye.